Hey everyone, and welcome to another episode of CNC Basecamp. One of the super cool things about owning a CNC router is all of the different materials that you can work pretty easily that maybe you couldn't before. I've always enjoyed working with metals. They're so versatile. Particularly, I love aluminum. But you know, before my CNC router, hacksawing, more filing yet. But with the CNC machine, it's pretty easy to cut. So, today on Basecamp, it's aluminum cutting basics. Well, first off, let's talk about different types of aluminum that you might use. My two favorite kinds of aluminum are 6061 multi-purpose aluminum and 7075 high-strength aluminum. So what's the difference? Well, 6061 has a yield strength of about 35,000 pounds per square inch and a hardness on the Bernal scale of about 55. So it's a pretty good metal. It's lightweight, it resists the weather nicely, it's workable, it's formable, it's a good combination. The next type of aluminum that I like to use is 7075 high-strength aluminum. 7075 was originally created for the aircraft industry. It is the aircraft grade aluminum. It has a yield strength of approximately 73,000 pounds per square inch, and the Bernal hardness rating is 150. So it's quite a bit tougher than 6061 multi-purpose aluminum. So where would you use it? I'll give you two examples. Let's take a look at this little project. This is a coping saw that I made for Woodsmith. And the frame of the saw is a lamination of ash and two separate pieces of 1/32 inch thick 7075 high-strength aluminum. And that lamination made for a very lightweight frame, but very tough. And that's what I was looking for. These other parts here are all 6061 multi-purpose aluminum because I just didn't need that high-strength element. Another project that we've recently made here at Woodsmith that uses 7075 aluminum is an architect's table. The quadrants were milled out of 7075. It just made sense. A little extra strength where it really counted. Now for any of these types of aluminum, what are the best bits? What are the speeds? How do we proceed? One bit that I really have found very, very useful for all sorts of aluminum milling is this guy right here. This is a 1/8 inch single flute Super O style bit, 1/4 inch shank. So why 1/8 of an inch? One of the things we're going to see here today is I've got a series of about 9 parts I'm going to be milling in this sheet here. That means 9 parts. Each one has 2 kerfs. That's 18 different kerfs. What if I were to use a 1/4 inch bit on that? Well, that's a lot of material being wasted by a large bit. And that larger bit takes a little bit of horsepower to turn. When I use an 1/8 inch bit like this, that small kerf conserves material. And nothing's cheap anymore, is it? So if we can cut down the amount of waste, we're ahead of the game. And that 1/8 inch size works well with small routers and spindles. And 2, it gets into corners nicely. So instead of everything looking filleted, it looks pretty sharp. The single flute style is what's right for aluminum because aluminum is a gummy metal and that single flute will help lift and clear the chips out pretty easily. A 2 flute bit will tend to gum up and before long, it's broken. Now in use, when cutting any kind of a metal, what's imperative is that we supply a little bit of lubrication and we keep that kerf clean of chips. Chip buildup equals broken bits. So I'm going to use a little bit of compressed air set at a very low setting, about 20 pounds per square inch, and I'm going to be blowing that kerf out when I need to. If you can set up a vacuum system, that's better. Vacuuming the chips is better. But for me, I'm going to go ahead and use the compressed air for right now. As far as lubricants, I've kind of settled on 2 choices. One that's super easy, and what we're going to use today, is an aerosol can of cutting oil. And this is just a multi-purpose oil for tapping, drilling, milling work. It works great. It's fairly light, simple to use. When I have a lot of work to do, sometimes I'll use what's in this spray bottle here, and it's a product called plumber's lard. Not a very glamorous name, but it is a stabilized lard oil, and it really works well for all sorts of milling applications. It's inexpensive, about $25 for a full gallon, and that's kind of my standard go-to for a lot of operations. So the next question is, what about feed rates and cutting depth? For a little bit like this, I have found that a cutting depth of 0.025 works fantastic. Now I know typically we read that when setting up cuts using router bits, we usually use a cutting depth of 1/2 the diameter. But milling metal with a CNC router is a different game. You can't do that. It's got to be a lot less. If you're between 0.02 and 0.03, that's where you want to be for most applications. As far as the speed, I found that between 50 and 60 inches per minute is pretty much ideal. I realize that if you go to chip calculations, it'll probably tell you to push the bit a little faster, but I find with the issues of rigidity on our hobby routers, the small size of the bit, the correct feed rate is about 50 to 60 inches per minute. It really works well. What I'm looking for is good, solid chip formation, and I'm seeing that and I'm getting that reliably with that depth of cut and that speed. Because good chip formation means lower heat, means longer bit life. So with that, let's talk a little more about our project and we'll get started. So today's project is going to be a series of hooks. This is an example of one of them. I've got a stem here, which was bent into hook shape, of course, and then I'm riveting onto it a figure. Now, for today's project, I've chosen a meadow theme, so I have about 8 different hooks, and they'll look great for a kitchen, for an entryway, for a mud room, anything like that. If you would prefer, instead of a meadow theme, porcupines, bears, moose, or antique tractors, will go for it. That'd be great. It's all going to work out about the same in terms of the procedure. So let's talk a little bit about the workflow of getting a design together and getting to the point where we're ready to cut on the router. I started by making a series of different sketches. So of course here's the butterfly that we just saw. We've got a frog, a swallow, and so forth, all sorts of different figures. After I sketched my figures out, I went to the copier and I scanned each of them in. I then brought that sketch into my program, Inventor, that I use for a lot of design work. Let me come in a little bit closer here, and we'll go in on one of the frog's feet. And you can see the green lines here that are used to sketch over and create a toolpath. Now, it doesn't quite follow my sketch, and the reason is that I need to make sure when I create the sketch that the router bit can actually reach into all the different areas. The way I had it drawn, it's way too tight here between the toes of the frog. So the first thing I did with the frog and with any tight area of any of these sketches was I came in and I drew a circle at 0.126 inches as a starting point to know that the bit would have room to get in there. If you draw the circle at 0.125, the exact size of the router bit, your programming might not recognize it. That's certainly the case with mine. So 0.126, a little bit larger than the router bit, and I use that as a basis to then use a spline tool to create the balance of my lines. Once I finished the sketch, I then extruded a 1/8 inch representation of the figure that I want. I created a second sketch and then exported a DXF file. Now I realize some of you are also using SVG files, so whatever you need to export for your particular programming. With that done, I then went into Vectric VCarve, which is the program I use to set toolpaths. This is an 8 by 24 inch piece of aluminum, 1/8 of an inch thick, and I use the nesting tool to place all of my figures. I have 2 tool paths created. One of them is a series of pocket cuts which create a texture on the back of the frog. The cuts don't go all the way through. They just go in about a 32nd of an inch. The last cut is a profile cut in which we'll cut out all the different shapes. As you can see here, there are yellow boxes along the profile. Those represent tabs, which will help keep the part centered within the curves as we cut the figures out. Well, with the tool paths done, it's time to go to the router and start cutting all of our parts out. Well, we've got most of the stems all cut out, but there's one remaining. And it is a plant with kind of a fiddlehead, a little spiral up there. I'm going to take a different tack with cutting this one out. For all the other stems, I use tabs to hold things together. Those tabs, of course, have to be cleaned up later on. Well, I really don't want to put a whole lot of tabs within that tight area because that's going to be fussy and a nuisance to deal with. So I'm going to go back and use a technique that we talked about in episode number 6, metal inlays. And that is, I've used good old hide glue, and I've actually glued this piece of metal down to a piece of MDF. That hide glue is tough. I cleaned the back of the aluminum, put a good coating of it on, and clamped things up for 24 hours. That's going to support the metal as it's being cut. When I'm done, I take the metal, the MDF backer, and I throw it in a tub full of water. In about 24 hours, it pops off, no problems, and most importantly, no tabs. Because tabs are necessary, but I'm not a real big fan of cleaning them up all the time. I do want to point one thing out. I had talked about our little bit before, and one of the reasons why this bit is so great is it's short, and the cutting length is 5/16 of an inch. So we want to always use the minimum cutting length required. And the reason is a longer cutting length, it just brings upon more vibration, more deflection of the bit, and that can lead to a rougher cut and breakage. So we always want to make sure that the cutting length of the bit is the minimum we can get away with. Well, there we go. As you can see here, we've got a nice tight cut and no intricate little web of tabs to deal with later on. Well, it's time to cut all the little figures for our hangers. So same bit, same procedure, only in this case we're cutting a piece of 1/8 inch aluminum plate. Now when I start out here, the machine is going to cut some shallow pockets which will be texturing for the frog's back. We'll then switch over to a profile cut and all the individual parts will begin to take shape. Well, with all the parts cut out, the next step is going to be some sanding work to give a nice even finish. And as you can see, I was just using a random orbital sander. This random orbital sander has a piece of Abranet. It's 180 grit, and that seems to really work well, but aluminum oxide pads will work fine too. It's a lot easier to sand everything initially when it's still in a sheet like this. That's how I handled all the different hooks, and that's how I'm handling the little figures which we're going to rivet onto the hooks later on. As you can see, these are still held in place with the tabs. So my next step for these is to get them knocked out. To do that, I'm going to use a cold chisel. And this is just a fairly small one, about 3/8 of an inch, and it's a sharp cold chisel. I made sure to grind a good edge on it. And there we go, it's separated. So I am going to need to take a file and file off the sprues left from the tabs. Or if you have a, depending on the shape, if you can use a sander, that's fine too. Once these are all separated, our next step is going to be to work on the hook itself. Now if you remember that fiddlehead design, I have it here. What I've done is I pre-sanded everything, of course, using the orbital sander. I used a little bit of paper to knock the edges off, and I'm ready to go ahead and make the bend to get it into a hook shape. And that's what we want in the end. We want a nice, gentle arc to everything. Consistency is very important when making bends because we need everything to be uniform. If it's not going to look its best. So to make a uniform bend, I've created a simple jig. I have a piece of 1.5 inch thick wall tubing and a piece of 1 inch thick wall. Now the fact that you could use anything, it really doesn't matter that they're that exact size, that they're gas pipe, water pipe, use what you've got. This happens to be some thick walled steel tubing we had here in the shop. Main thing is when placing the part, make sure that you're consistent in how far it goes through the two tubes. And then what I'm going to do is just very gently bend the part. So this is my first step where I have the end of the hook essentially parallel to the rest of it. Now I'm going to open things up a little bit. I'll put it back here in this between the two pipes, and I want to open it up a little bit, and I'm going to compare it to my hook out here, which is my standard, and I see I need to open it up a little bit more. And just a tiny bit more, and I think we are going to have it. All right. Next thing I need to check is I want to make sure that the back of the hook is flat. Right now it's rocking just a little bit. So I'm going to use my two pieces of pipe, and I'm just going to put a slight bend, because what I would like to have is a slight arch so that when I put a fastener and screw this to the wall, it flattens out. So that looks good. Well, with all the hooks bent and with all the parts cleaned up and sanded, it's time to start riveting them together. Now I've got to start on things, but let me show you how it's done. So I'm going to go ahead and use the frog as our example. As you can see, there's a hole bored through the frog to accept the rivet and a hole in the hook, and I've got that area around that rivet hole a little bit enlarged for extra strength. The rivets that I'm using are soft 1/2 inch long rivets. So first off, we'll just put the rivet through the frog. Now if the hole is tight at all, ream it out. Don't try and force these. The rivet is soft enough. You're going to have problems if you try and force it. So with the two parts together, we want to make sure the frog is pretty much in the right position. I'm going to flip it over and place it on the anvil of my vise, and I'll go ahead and gently peen the rivet. Now there's really no need to countersink or do anything like that to create a cone for the rivet to go down into. It's soft enough and the blows of the hammer are hard enough that it swells out and locks things in pretty tight. I can also flatten the rivet down enough that I don't have to go back and file things smooth. There's a little projection here, of course, but it'll still seat firmly against the wall. Well, here's our completed hooks, and I'm pretty happy with them. Now, everything we've done to create these hooks, hey, it'll work just as well if you're making a bracket for your boat or a part that you're going to use on some deck furniture, whatever the case. Aluminum is a strong, versatile, weather-resistant metal, and it's a joy to work, and there's so many things you can do with it. Now, I chose a meadow theme for my hooks, but you know what? Bears, porcupines, moose, or antique tractors, it's all going to look good. Now, the files for these hooks are all available. Just go to the Basecamp website, hit read the article, and down at the bottom you'll find a link for the downloads. I'll have the files in both DXF and SVG format. So, I hope you enjoyed today's episode, and I hope you'll join me next month for another episode of CNC Basecamp. Aluminum is an amazing material for us to work with on our CNC machines. It's strong, it's lightweight, it's easy to cut. You can bring it up to a beautiful mirror-like shine or soften it with a little sandpaper or a Scotch-Brite pad. But sometimes, wouldn't it be nice to have some color, to have some choices? Well, I was really excited the other day when I ran across some chemicals for creating a patina on aluminum. And we're going to try a few today. The company I bought these from is called Surfin out in California, and the colors that I purchased were red, pewter, and brass. So let's go ahead and go through the process. Now, with any kind of metal treatment, there's a learning curve. Well, I'm pretty far down that learning curve right now. So the results we're going to get are going to vary a little bit, but I think they'll give you a great idea of the possibilities, the potential for using a patina finish on aluminum. Now, the first thing I've done here is to take my aluminum and I've sanded it. We want to get rid of all of the imperfections and any splotches, oils, grease, anything that might be on it. So I've just used a fairly coarse 80 grit pad and a random orbital sander. The next step for us to do is to use a cleaner. So I've got a cleaner from Surfin here. Got my gloves, and I'm going to take a brush and gently massage a little bit of this cleaner on the surface of each one of these sample pieces of aluminum that I have here. Consistency in the preparation for a patina is very, very important. After the application of the cleaner, the next step is to go to the sink and to clean all this off and thoroughly dry the samples. All right, with our samples sanded and treated with the cleaner, time to start applying patination chemicals. What I'm going to start with is this one, which is a brick red. There are different ways that you can apply the chemicals. You can brush them on, you can roll them on. I'm going to use a small sprayer. I think it's kind of a handy way to apply the chemicals and give it a kind of an even mottled finish that'll blend in nicely as it begins to react. So this is not a lightning storm patina agent. It's going to take about half of an hour. So let me get it wet. Don't expect anything amazing to happen. We have to be patient and give it a little time. I want to make sure I've got it thoroughly coated, and it is, and we'll just wait. The next color I want to do is a pewter gray. And this is kind of an interesting process because it requires two parts. There's an A and a B. Part A is going to put a cement gray coating on our aluminum, and it provides the chemicals needed for the reaction for part B. So let's go ahead and put a little bit of the part A in place, and you'll see it turn gray. And I'm going to gently spread it all over the panel. And part A requires a couple of minutes, but no more than about 3. And then I'll take it to the sink and wash it off. So I want to check my wristwatch here. Seems to be well spread. And you can see it is depositing a layer of chemicals, a layer of metals on top of the surface. Well, with part A in place, it's time to spray on part B and see what happens. So once again, I'm using a small spray bottle for a little more even application. Hey, look at that. That's kind of exciting. So fairly consistent. I've got a little spot here, and that's my fault because when I was drying off part A. I rubbed through a little bit. But that looks pretty nice. Now, one thing they say in the instructions is that after everything is dry and set, you can use like a fine steel wool and blend things a little bit. You know, sometimes with like blacksmithing work, when you have a black iron, rubbing things down with a bit of steel wool to pull out that bright steel along edges can really make a difference. It's kind of like a sand-through finish with woodworking. So part B is supposed to sit no longer than about 1 minute. So I'm going to take it to the sink and wash it off, and we'll move on to the brass. Well, the last of our samples is brass, or gold colored. And like the red, it's a single part patination process. So one chemical, and I'm going to just lightly brush it on. Well, you gotta love that deep magenta color of this chemical. That is fun. Make sure it's evenly applied. And we'll give it a couple minutes and I'll wash it off. Well, here are my finished samples: brick red, pewter gray, and gold brass. So I'm still learning about the application technique. So I've got a little bit more practicing to do and a little bit more learning to really feel like I can control these finishes well. But I think they're really exciting. Now, with all of these patina finishes, it's important that you seal them after they're dry. Now, you can use a solvent-based sealer, or I really like the acrylic, the water-based sealers that are now available. You can get them interior and exterior, and my experience is they really hold up and they're super easy to apply. So there you go, some fun options for aluminum when working with your CNC.